All right, so hey everybody, I hope everybody's doing well. Getting excited for the Regents coming up next week. Here's the June 2010 Regents answers, and here's how I did each one. So problem number one, what's the common difference of the arithmetic sequence? I wrote them out, and I tried to find the space between them, you know the difference, and it turned out to be 3. And that's it. It's easy. What's the number of degrees in an angle whose radian measure is 11 pi over 12? Well, I happen to take a cheap shortcut in that whenever I convert from a radian measure to a degree measure, I sub in 180 for pi because that's how many degrees pi is in radian. That's how many degrees a pi measure is in radians, and then I get 165. So make a long story short, just sub 180 in for pi, and then reduce. That's 165. A is 3, B is -2. What's the value? You sub those in, use your calculator. You know, first I subbed it into the top. I found that this was a ninth. Then I subbed it into the bottom. I found this was an eighth. And then I entered this into my calculator, a ninth divided by -1/8. And so, you know, you get -8/9. 4 points in the graph. The function is shown below. Take each one of these, enter them into your calculator, and look at the table of values. That's all you got to do. The graph is shown below. Let's switch back out a little bit. So let's go out even more so we can read the whole thing. Graph shown below. Which set lists all the real solutions? What you do is the real solution. So where is y equals f of x? Basically, y equals f of x. And so you could sub a y in right here. Where is y equal to 0? Well, it's equal to 0 at -2 when x is -2, 0, and 3. That's it. Right there. 6 in simplest form. Remember, anytime there's a radical underneath there's a negative underneath the radical, you bring that out, becomes I, and then you just simplify the radical. It's a radical 100 times radical 3. It's 10I rad 3. 20 different cameras. We're going to be assigned to several boxes. 3 cameras will be randomly selected. Which expression can be used? Order doesn't matter, so it doesn't matter the order that you're picking them out. No camera is assigned a specific duty. When order doesn't matter, use C. There's 20 cameras, so it's 12C3. Factor completely. Look at all these guys. They all have x squared in common. 2x squared. Ooh, look at that. So this is the GCF. Pull it out. And then this is a complicated thing to factor. Use the AC method. Take the first number, multiply it by the last, get -36x squared. Then find two numbers that multiply to be this but add to be that. Sub them in right over here. Group these two together. Group these two together and factor out their greatest common factors. If you do it correctly, then the stuff in the parentheses always matches. Take what you factored out, this and this, put it together, and take one of these parentheses and put it next to it. And then you basically have this thing factored. Bring this down next to it, you're good. Another way you could have tried to attack this problem is literally by multiplying all these things out, but that's really annoying, but you could always do it. I would do it if I were on the Regents exam. And I didn't know how to do this. The solutions of the equation are, what did I do? I set it equal to 0. It's impossible to factor, so I use the quadratic formula. Quadratic formula is -b plus or minus b squared, square root of b squared, minus 4ac all over 2a. A is 1, that's the number in front of y squared. B is -3, c is -9. Plug them all in, simplify it down, and that's it. Logarithms. First thing you do is numbers in front of the word log can pop back up into the exponential spot. So this 2 pops up, and this 3 pops back up. Anytime you're adding two logs, you are essentially multiplying their resultants. That's just one of those rules of logs. So anytime you're adding two logs, multiply these two things right here. Those get put together. And anytime you're subtracting logarithms, you are dividing the results. So this is being divided by this quantity right here. That's it. You could have also have used your calculator and plugged, assume some numbers for x, y, and z. This is a SAT type way to solve the problem. So you could have assumed x was like, I don't know, 4, y was 5, z was 6. You could have used your calculator, plugged these numbers in, and then when looking for the answer looking for a number that matched in the answers. But that's really kind of like a barbaric way of trying to attack this problem. This is the more elegant and more appropriate way to solve it, but it's multiple choice. You just have to get the question correct. This question right here, the first thing you want to do is whenever you have a negative exponent and you want to look at it in positive form, you just rewrite it as its reciprocal. So this quantity right here gets rewritten as 1 divided by x squared to the 2/3, and 2/3, this is the exponent, this is the index, it's just the cubed root of x squared minus 1 squared. So it's that one right there. You got a fraction and there's some radicals in it. Multiply by the conjugate, top and bottom, reduce it down, multiplies out. Everything over here can be divided by 2. So there you go. Which relation is not a function? Well, that's a line, that's a hyperbola, and that's a quadratic. This guy right here is a circle. It's not going to pass the vertical line test. This guy right here is not a function. Cofunctions are equal when their angles are complementary. So use your calculator. Let me show you this one. Let me show you this one in your calculator. Well, okay, let me show it to you in your calculator, and then I'll explain what I wrote on the side. First thing you want to do is let's inverse the tan of 2/3. Find out how much angle A is. Right? A is like 33.69 degrees. And so now we're going to go looking in our multiple choice and find which one, basically when you sub this weird number in for A, makes the other side, 2/3 or a third or whatever it is for that multiple choice. I'm going to do this one right here because I know it's the right answer, and I'm just going to show you how it works. Cotangent is just 1 divided by the tangent. And I'm not going to attempt to write that answer in there because I'm really lazy. I'm just going to cut and paste it. That's what I did right there. And hit enter, and look at that. It's one, like 1 divided by the, I messed up. My bad. Let me start over again. Inverse the tan of 2/3. You get this weird number, and then here's where I messed up. Cotangent is 1 divided by tan, but I forgot to do the 90 business. So that's 90 minus the answer. It's a 0.6667 math. Convert that to a fraction, it's 2/3. Now, like this other thing that I've written down right over here is this is a property from geometry. You should have learned it in trigonometry. Basically, cofunctions are equal when their angles are complementary. So sine and cosine are cofunctions, hence the word co in front. And so like the sine of 30 is the same thing as the cosine of 60. So you can take a cheap shortcut that way. All right, number 15, we got an exponents type problem. Just you need to convert these, give them the same base. 4 is just 2 squared. Check it out. Now you have to make it rain, drop this in there, it multiplies that. That's a rule of exponents. Because they have the same bases and it's an equation, take the exponents, set them equal to each other, and solve. Check that out. Now this is actually the long way of solving the problem. I'd prefer you to do it this way because it's good practice in case it was a short answer question. You could also simply have just taken the multiple choice answers and plugged them in and found which one worked. Oh my God, 16 could be the most gangster problem on the entire Regents. You have to use completing the square twice in 16 to create a circle. So here's what you do. First of all, anytime you see x squared and y squared, it's a circle. It could also be an ellipse, but we're not going to talk about that. That's a pre-calc type business. Group the x's together, group the y's together. That's what I did right here. Move the 3 over to the other side. Then put these guys over here in parentheses, put these guys over parentheses, and complete the square. Take this, divide by 2, square it, add it to both sides. Take this, divide by 2, square it, add it to both sides. And then, simplify it. This thing right over here is just x minus 1 squared. This guy over here is y plus 3 squared. That's it. That's all you got to do. I'm not going to lie, that one's hard. Which graph represents the inequality? Use your calculator. I mean, okay, look. Well, which graph represents, first of all, minus 6 over to this side. We got to get it looking like that. And then here's what I did. Turn your calculator on. Check this out. That's my other problem. We're going to enter this in. X squared minus x minus 6. And then take a look. This thing reads y is greater than or equal to this quantity. Greater than, greater than. We are shading up towards that higher power. Yep, yep, towards the higher power. Shade up, hit enter. That's a solid line. Shading up looks like that. Hit the graph button, check it out. Booyah. Take a look. Which one does it look most like? Yep, it looks like you because look, your vertex is on this side and your vertex is on this side. This one is a real sneaky question. Its vertex is on the left side. It's very sneaky. So, it's choice 1. The solution set, do me a favor, you don't have to do anything other than just plug these answers in for x and check. This side has to equal this side. Use your calculator. It's a piece of cake. This one, also use your calculator. Let's go over this though, because I always get asked questions in class about how to do this. Look, anytime you do anything like I to the 7th, at a certain point your calculator goes haywire when it tries to do the i's, unless you plug it in a particular way. And so here it is. Here's how we're going to plug it in. Hit the math button, go over to number, go over to I part, and then inside the I part, do whatever you want with the i's. Won't make a difference right there. I to the 7th times I raised to the 5th. The answer is just 1. There you go. That's how you use your calculator. I part, baby. I part. Oh, which equation is represented by the graph below? Come on now. Once again, using the calculator. Okay, this right over here is in radians. My calculator is already in degree mode. I don't feel like switching back and forth. You know, that could really mess things up. So I'm just going to convert this to degrees in my mind. 2 pi is 360, 3 pi over 2 is 270, pi is 180, pi over 2 is 90. So here's what we're going to do. We got to make our x min 0 because there's nothing over here. We're going to make our x max 360. Whoops. My bad. We're gonna make our x max 360. We're gonna scale it by 90. Y min. Let's see if we could actually catch this with it being like negative 10 and 10. I'm not gonna adjust that yet. Let's see if our picture gets all messed up. Hit the clear button. Make sure that that's all cleared out. And now I'm gonna plug in one that's bad and one that's good. Okay. First I'm gonna plug in tan x because there's a tan on here. Let's see if this thing right here is tan x. No, not tan x. Clear. Now let's do secant. Secant is the same as 1 divided by the cosine. It's just one of those things you got to remember. Yep. And that's the secant. Now some calculators, this straight line coming down is actually the asymptote. You just have to know that on your calculator. Some calculators write in the asymptotes, other calculators don't. What can I tell you about that? But this one really does resemble our picture, so I'm choosing that. I'm choosing choice 3. Which value of r represents a strong negative correlation? R is the degree to which two things are correlated or related. If it's negative, they're moving in opposite directions, like playing Xbox all night and doing well, and your grade on your Regents exam obviously go in opposite directions. The more you play Xbox all night, the worse you're going to do. But that would be a negative correlation, and the most a negative correlation can be is -1. Two things that are positively correlated are studying and doing well on your Regents exam, and they would have a correlation of 1. So correlations are bounded between -1 and 1. That means you could immediately cross off this one. This one's not even negative. Cross U off. And of the two remaining choices, this is the more negative. Choose this one. To be honest with you, I wrote the wrong thing here. This is one of those things you have to remember. In order to create the inverse for tan x, the engineers that designed your calculator had to restrict its domain. And they restricted its domain to -pi/2 to pi/2. You have to remember this. I'm sorry I wrote use your calculator. This should say fact you must remember. My bad. You have to remember this. Remember this. Remember this. Did you remember it? I'm just kidding. But seriously, remember that one. Um, okay, in the diagram below, what's the measure of k to the nearest minute? Oh, this is a good one to show you in the calculator how to do. Let's clear this out. K, so here's the adjacent side. That's the hypotenuse, so we're going to use cosine. We're going to inverse the cos of 5 over 6. Now, this is a fractional part of a degree. Degrees can't be measured by a ruler, and so their measurement is really on the minute scale, which is, on a clock. And so where do you find that kind of conversion? It's in your calculator right over here. It's the angle. It's above the apps button. Second, apps, my favorite wrapper, DMS. This stands for, by the way, degrees, minutes, and seconds, but I joke around that it's my favorite wrapper. Hit enter, and it's 33 degrees, 30 minutes, 33 minutes, 26 seconds. These go in units of 60. Remember that if they ask you to round. So to the nearest minute, because this is 26, you round down. If it were anything above 30, you would be rounding up, and that would be 34, but it's 33. The expression, this thing is equivalent to, so the 2 over here, anytime you see the 2's placement right here, this is an identity, and these are found on your reference sheet. That's at the beginning of your green book, or if you are using a printout of the Regents exam itself, it would be at the end of the Regents exam. Look at the reference sheet. And then it's really a kind of like a luck of the draw type deal. You try some things, you see if they work. One of the identities, if you sub it in, this one in particular, check it out. You sub it in for cos 2 theta, distribute the negative. These two cancel each other out, and you're just left with sine squared theta. You're just trying to build out this sequence in 25. This is called sigma notation. You start here, you go up to here, you plug in whole numbers 1, 2, 3, 4, 5, 6, 7. And so you want to just plug in until you find which one of these formulas builds this exact sequence. And it's choice 1. What's the formula for the nth term? This guy right here also, just plug in 54. The number that you plug in for n is its term. So if you wanted to find the first term, which is 54, just plug in a 1 right here. And if you plug a 1 right in here, you plug a 1 right in here, 1 minus 1 is 0, and you're just left with 54 because that'd be a third to the 0. Then to get 18, you plug a 2 in right here. So a sub 2 means the second term. And 2 minus 1 is 1. 54 times a third raised to the first. It happens to be 18. So you just go through it and try and find the formula that works, and it's this one. What's the period? This one requires a little bit of work, not too much. You see this thing right here? We got to factor it out. Find b. b is this number right over here. Both these guys, it's how it's like x. It's almost like x over 3. Well, it is x over 3. I factored that out of each of these and found out how much b is. C at the end is a shift left or right. B, the period is 2 pi over b. That's 2 pi over a third, and 2 pi divided by a third is 6 pi. Short answers, use the discriminant. Find to determine all values of k that would result in the equation having equal roots. When an equation has equal roots, the discriminant equals 0. So b squared minus 4ac equals 0. Then you sub in these numbers. B happens to be negative k. A is 1 and c is 4. Plug them in, you get this. Then you have to factor that, solve, and those are the two values for k that will result in the discriminant having equal roots. This guy right here, let's see, find the population standard deviation. Just break out your calculator, hit stat, edit, list 1. You want to enter all these numbers in. I'm not going to make you watch me do that. I'm just going to plug them in real quickly. Right, so basically I plugged the test scores into list 1 and the frequency into list 2, and then here's what you do. You hit stat, you go to calc, you go to one variable statistics. That's all you use in this class. You hit enter. You go L1, need all the data from L1 and L2. Hit the enter, prints you up all that stuff. Which one of these guys is the population standard deviation? It's this one right here. It even looks like a little p for some weird reason. And so take this one, and that's it. Just round it to the nearest tenth, 7.4. Find the sum and the product of the roots. These are formulas you should remember. The sum of the roots is negative b over a, and the product of the roots is c over a. And you just plug in, you know, a is 5, b is 11, c is negative 3. That's it. Graph that equation. You just plug it into your calculator. You got to plot some points down. Don't just draw any graph. I plot this point over here. This is where x is 0, and anytime if anything raised to the 0 power is 1. It's kind of like just a really important marker. If you look at your calculator, it's going this way. That's important. There is no way that this graph breaks past the 0 line. That's because even if you get negative numbers, when you have negative numbers up over here, it's going to flip the fraction and make big numbers actually as the y value. And when you have a positive value for x, it's going to make the fraction keep multiplying itself, square to the third, to the fourth, to the fifth, which will produce really low numbers. And hence it will get really, 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 really close to 0, but it will never get there. That's what it means to be an asymptote, to get really close to something, this value, but never get there. It's an asymptote. Express this in simplest radical form. All I did was break it up, you know, break this up, break that up. I'm separating things out. 27 is just square root 9 times square root 3. Square root of 9 is 3, x cubed. I broke this stuff up. When you have variables raised to an odd power, break them up into things that are perfect squares. So x cubed, that's the same thing as x squared times x. X squared is a perfect square. So then you can actually get rid of the radical on top of it. Right? So it's like 5x rad 3x. And over here, square root of 9 is 3, x cubed. Well, breaking that up into x squared times x. Square root of x squared is x. There you go. 5x minus 6x is negative 1x. On the unit circle shown diagram, sketch an angle in standard position whose degree measure is 240. 240 drops you over in the third quadrant. Always have to start here. Always must start right here. And if you have a positive degree amount, you go counterclockwise. If you have a negative degree amount, you still start here, but you'll go downwards. And then sine 240, you plug it into your calculator. In my class, sine 240, I had them remember that anytime you see 0.866, it's rad 3 over 2. So it's going to be negative rad 3 over 2. Two sides of a parallelogram are 24 and 30. First thing you got to do is draw a picture. The measure of the angle between the two sides is 57. Find the area. This is a formula you must remember. It's kind of on your reference sheet. It's the area of a triangle, but there are two congruent triangles that create a parallelogram. So instead of doing a half times 24 times 30, sine 57, you just do it by, 24 30 sine 57. So take out that half business when you're trying to find the area of a parallelogram, because there's two of them, and two halves make a whole, or one. Oh boy, this is a crazy question. So here's what you do when you have fractions. If you see a fraction on your Regents exam, don't freak out. I know it looks crazy. You need to find the least common multiple of the denominators of this, this, and this. And so 2d and 2d, the least common multiple is 2d. Distribute that in. Okay, multiply top and bottom by 2d over 1. Watch what happens. Something magical happens. So in any event, so when you multiply it in, look, 2d over 1 times a half, that's top times top, bottom times bottom, that's 2d over 2. 2d over 1 times 4 over d, that's 8d over d. And so that's d minus 8. Distribute this in. The d's reduce. 2 plus 3. 2 plus 3 is 5, and then you get d minus 8. Oh boy, study the men's club shown a choice of wearing black or red vests at the club meetings. A study done over a period of many years determined that the percentage of black vests worn is 60%. If there are 10 men at a club meeting on a given night, what's the probability to the nearest thousandth that at least 8 of the vests will be black? Okay, so at least, which means we're going to have to use our probability formula. Whenever you see a question with probability like this, exactly, at least or at most, you want to write out the N, R, P, and Q. N, total number of things that you have. We got 10 men at this event. R, total number of things that you want. Since we want at least 8 of them to be wearing vests, that means we could have 8, that's good. We could have 9, that's good. We could have 10. P is the probability of success, and the probability of success that somebody wears a black vest is 60%, and that means the probability of failure is 40%, or 0.4. Then you need to calculate the exact value of this occurring, and this occurring, and add them together. So it's NCR, P to the R, Q to the N minus R. It's 10C8, 0.6 to the 8th, 0.4 to the 2nd. In other words, we want 8 people wearing a vest, 2 people not, 9 people wearing a vest, 1 person not, 10 people wearing a black vest, 0 people not. Take these, punch them into your calculator, add up those probabilities, and you get 0.167. This is a crazy question. It's called a trig equation. What do you have to do? Well, like I said, anytime you see this, anytime you see that tube placement right here, look at your reference sheet. Find an identity for it. Okay, that tube poses a problem right now, but if we could get rid of it, this problem would be really easy to solve. So this quantity right here, sine 2 theta, can be subbed out for 2 sine theta cos theta. Subtract sine theta over. Both of these guys right here have sine theta in common. Factor it out. You're left with 2 cos theta minus 1. Set both of these things equal to 0. Right? Solve inverse the sine of 0 to find theta. You get that sine that 0 degrees works and 180 degrees works because, so remember, sine represents the y values of the unit circle. Where are the y values at 0? They're at 0 degrees and also at 180 degrees. Cosine. Let's see. For this one, we're still going to do the same thing. We're going to inverse a half. Find theta. That gives you 60. But where else is the cosine positive? Okay, cosine is positive in quadrant 1 and quadrant 4. 60 degrees will work. This creates our reference angle. And 300 degrees will work. The letters of any word can be rearranged. Carol believes the number of different 9-letter arrangements in the word Tennessee is greater than the number of 7-letter arrangements in Vermont. Is she correct? You know, the problem with Tennessee is although it has more letters, they repeat themselves. So when you rearrange things, it's not necessarily unique. And so here's how you do it. Whenever they see this question, this is a factorial question. There are 9 letters, no doubt about it. 9 factorial ways they can be rearranged. But then you have to divide out by the number of repeats. In other words, repeats of the S's, 2 factorial ways that can be done. Repeats of the N's, 2 factorial ways that can be done. And then repeats of the E's, there's 4 factorial ways that can be done. And so the total number of actually unique combinations that can be made with Tennessee is 3,780. For Vermont, there's no repeats, so it's just 7 factorial. It's more. So she's actually wrong. And then finally, last question on the test. In a triangle, 2 sides measure 6 and 10, form an angle of 80. Drew a picture of it. Find to the nearest degree the measure of the smallest angle in the triangle. Well, see, so here's the problem, really. You don't know which one of the angles is smallest. What you need to do is figure out which one is the smallest side in this triangle, and then look opposite that side. That is the smallest angle. So that's what I'm going to do. I'm going to use the law of cosines and find how much a side C is. Side C turns out to be 10.7 after you plug into the law of cosines. The law of cosines can, by the way, be found on your reference sheet. And so side C is 10.7, which means angle A is the smallest angle. So 6 is to the sine, then I'm going to use law of sines to try and figure out angle A. 6 is to the sine of A as 10.73, whatever I got in my calculator, is to the sine of 80. Cross multiply, divide, right? To find angle A, inverse this. Sine inverse of this business over here equals A, or angle A. And angle A turns out to be 33 degrees, and that's the smallest angle in the triangle. And that's actually the end of the test. I hope you enjoyed it. I hope you learned a lot. Please let me know if there's anything else I can do to help. Good luck.